In this problem, an arrow is shot into a block of wood, causing the block of wood and the arrow to slide across a surface. Friction is not ignored here. First of all, stop the video and copy down the question. Now that you have a record of the question, let's begin solving it. Well, there are two things that we need to consider. We need to consider the collision and then the energy conversions in this problem. So let's just write that down. So first of all, the collision occurs, and second, the energy conversions or conversion occurs. So my initial approach, I'm going to try to solve this sequentially, starting at the beginning of the series of events and then moving forward. So let's have a look at the collision first. So according to our understanding of momentum, momentum is always conserved. So sum of Pi is equal to sum of P final. So initially only the arrow is moving, so it has momentum. Let's call the arrow object 1. M1 V1 initial is going to be equal to the combined system. This is a perfectly inelastic collision, or complete inelastic collision. The two objects combine to form a single system, and they end up having a final velocity. So let's plug in the numbers. 0.025 kilograms for the arrow, and we don't know what its initial velocity is. That's what we want to find out. The combined mass would be 0.025 plus 1.35 for the block. And we don't know the final velocity of the system. So we have two unknowns there. So we can't solve the problem just yet. And I'm out of stuff to do with the collision. This is an inelastic collision, so there's no additional formula that I can use. So what I'm going to have to do now is explore the conservation of energy and come back. So let's do that. Actually, let me just make a note here. We don't know this and we don't know that. Right. Two unknowns. Okay, so it would be a system of equation approach in solving this, or identifying two equations and taking one equation and using that to uncover one of these two unknowns. That's what I'm going to do. So we have the sum of the energies. Initial is going to be equal to the sum of the energy final minus work done by non-conservative forces. So we don't have any final energy in this case. All the energy is converted into, or all the energy is consumed by the friction, or converted into work done by friction. So let's just eliminate that right off the bat, and let's start expanding this. Post-collision, the objects are together, so M1 plus M2, and they have a combined velocity, which I'm going to call VI squared. And then that is going to become the work done by friction, which would be FF times D. Now that negative sign in there will end up canceling because the force of friction is going to be in a negative direction. So that gets taken care of later. So what do we do? I guess the next step would be 1/2 M1 plus M2 VI squared is equal to negative, and I'll do this, negative mu mg times d. Okay, I'm inserting the negative right there because that product of mu mg, it will end up being a negative number. Mistake. So let's see if I can erase this. Okay, and let's fix this. This should say m1 plus m2 g times d. That's better. Okay, so I can now cancel the m1 plus m2 from both sides of the equation, and now I can start plugging and chugging. So we have, or let's rearrange this, let's simplify this. So v is equal to square root of, move the 2 to the other side, 2 mu g d. Okay. So v is going to be equal to the square root of 2 times the coefficient of friction is said to be 0.25, and this will be 9.8, and d we're told is 9.5. Okay, and so v is going to be equal to, let's plug that into the calculator, so 2 times 0.25 times 9.8 times 9.5, that works out to 46.55. Take the square root, and I end up getting 6.82 meters per second. Okay, so that ends up becoming the final velocity post, let's see, post collision. So that ends up being plugged into that spot right there. So let's finish the problem on the right side. Now what I want to do is I'm going to rewrite that over here on the side. So 0.025 initial velocity of the arrow is equal to the mass of the system, the arrow plus the block, times the velocity of the system, which we just calculated. So this right here becomes 0.025 plus 1.35, that's 1.375. So multiply that by 6.82, and then divide it by 0.025. And it looks like my arrow is traveling at 375 or 380 meters per second.